Let's practice with our trig derivatives. So we've got this function here. We'll start from easier, getting more complicated. Sine of 5x. I'm not going to write out all the steps in the chain rule this time. We've gotten some practice with it. If you want to write them out, the inside and outside function, that's great. But let's see if we can do it without that. We've got sine of something. So the chain rule says we take the derivative of the outside function. When we figured out recently that the derivative of sine is cosine. Now, what do we do with the inside function in the chain rule? Does it stay the same, or do we change it? It stays the same, right? The chain rule says it's f prime of g. The inside function g doesn't change. But the chain rule says you're not done yet. You have to take the derivative of the inside function. So the derivative of the inside function 5x is 5. So we've got sine of something becomes cosine of something times the derivative of something. Let's move on to this next one. What's the novelty of this? This is a double chain rule, right? You have a function inside of another function. So the innermost function is what? X cubed. The middle function is cosine. The outermost function is the exponential function. So let's figure out what the derivative of this is. So you'll notice we've always been starting with the outermost function. That's how I think is the easiest way to do it. So we've got 2 to the something. What's the derivative of 2 to the something? 2 to the, you tell me, same something or different something? Same something, right? That's the classic chain rule mistake to avoid. Don't change the inside function. So 2 to the something becomes 2 to the something ln2. That's our exponential derivative from last week. But we're not done. Now the chain rule says we move inside. We take the derivative of the inside function, or in this case the middle function, which is cosine. So you can forget all about this 2 now. All your job is to take the derivative of cosine of x cubed. So what's the derivative of cosine? That's what we just figured out. That's negative sine. Cosine of x cubed, should that inside function change or stay the same? I hope by now you're getting tired of me asking this question, but it should stay the same, right? So cosine becomes negative sine of x cubed. The inside function didn't change. Are we done? I hope you're saying no. Because there was still an inside function inside of cosine. That was x cubed. We have to take its derivative, 3x squared. Is that okay? How about this one? We've got tangent of x e to the 6x. So what rule or rules are we going to need for this? We are going to need the chain rule because we have functions inside of functions. But what other rule are we going to need? We're going to need the product rule, right? Because our inside function is a product, x times e to the 6x. But this is a case of a product inside of a chain. So we start with the outermost function, the chain rule. So we've got tangent of a thing. We learned recently that the derivative of tangent is secant squared. So we've got secant squared. So this was tangent of a thing. Should it be secant squared of the same thing or a different thing? Secant squared of the same thing, right? So x e to the 6x stays inside there. And now we can forget all about this tangent. We're done with it. We now have to take the derivative of the inside function x e to the 6x. For that, we need the product rule. So the derivative of x is 1. Multiply that by e to the 6x. Second part of the product rule says we leave the x alone. And now we've got to take the derivative of e to the 6x, which itself is a chain rule problem, right? Because it's e to some other function, not just e to the x. So what is the derivative of e to the something? That is still e to the something. But the chain rule says there's more to come. You've got to take the derivative of the inside function, so the derivative of 6x, which is 6. And we've got to put this all in parentheses because this is all the derivative of the x e to the 6x. Is that good? How about this one? Take a minute and try to decide what you think the outermost function is here. Cosine to the 4th of 5 times 6x, 6 to the x. Is the outermost function cosine or cosine to the 4th or what? So remember that this is our shorthand way of writing what? Of writing cosine of 5x to the 6th, all to the 4th power. So really the outermost function is the 4th power here. So if we're doing the chain rule, we start with the outside. We've got some stuff to the 4th power. What's the derivative of some stuff to the 4th power? It's 4, and then what? Same stuff or different stuff to the 3rd power? Same stuff, right? Chain rule says you keep the inside the same. And now I wrote it with these pair of brackets just to correspond with this. If you had written 4 cosine cubed, 5x to the 6th, that's the same. That's fine. So we've got that. Now we're done with the 4th power. We don't need to worry about it. We take the derivative of the inside. Derivative of cosine is negative sine. And if it was cosine of this, it's negative, the derivative is negative sine of the very same this, right? The inside function does not change. Is that the full answer? That is not the full answer, right? We're not quite done yet. We took care of the 4th power. We took care of the cosine, but what's left is to take the derivative of the innermost function, 5x to the 6th. For now, that is, we're really pros at that. That's just our rules from last week. Constant multiple rule and the power rule. The 6 comes down. We get 30x to the 4th. And these functions really do arise in real life. If you, for example, look at the famous Black-Scholes equation that they won the Nobel Prize in economics for pricing derivatives, it's much messier than these. The solution to that equation is much messier than these. All right, how about this one? Something that I find that people have trouble with sometimes is understanding whether we've got a function inside of another function or multiplication. They wonder whether this is saying a multiplication here or a chain rule. And what I find is useful is that if you actually read it out loud, you will get it right. So how do you read this? What do you say between sine and cosine here? You say sine of. And every time you say of, it's a chain rule. Sine of cosine of tangent of 7 to the x to the 8th. So each of is a chain rule. So there's no multiplication happening here, right? Because I can't just have an sin by itself multiplied by something. So this is a big, big chain rule. If you can get this problem right, you understand the chain rule. We've got sine of something. By now we know the derivative of sine of something is cosine, and the inside doesn't change. So sine of all of this stuff becomes cosine of all of that exact same stuff. Good? Now we are done with this sine forever. Not going to worry about it anymore. We take the derivative now of cosine. We know the derivative of cosine is negative sine. Stuff on the inside, what does it do? Change or stay the same? Stays the same, right? So now we are done with the sine and the cosine. Don't even think about them anymore. Now you've got to take the derivative of a tangent. We figured out that tangent's derivative is secant squared. And the stuff on the inside, as we all well know by now, does not change. Are we done? Not quite. We're done with the sine and the cosine and the tangent, so don't look at them anymore. You've got 7 to the something. What's the derivative of 7 to the something? That's our exponential rule from last week. That's 7 to the something times ln 7. Now are we done? We are not quite done. Because even inside of the 7 to the exponential function, there was an x to the 8th. So what's the derivative of x to the 8th? 8x to the 7th. And now we really are done. If you got that right, you understand the chain rule. Sometimes people aren't sure when to stop at the end. So if you weren't sure when to stop, you can think about the innermost function here as being x. X is inside of x, right? And what's the derivative of x is just 1. So you can sort of put a times 1 at the end, and that's telling you that now it's time to stop. And it is time to stop for us as well. We have a complete check your understanding for you to do on the derivatives of trig functions.